And we are in charge of the power, gas, water supply, and sewage management, and even waste management of Medellin, Colombia, and other cities in Latin America. So it's a big company. We have more than 16,000 collaborators, and it's across Latin America. And I want to show that we are in charge of Medellin sewer system. First, our program. This is our main sewer system. Which one is the pointer? The one? Sorry. Okay. So Medellin City is this city here, and we are a conurbation of 10 municipalities. Our main river flows from south to the northeast, and we have 2 wastewater treatment plants, and our main sewer system is located in the 2 sides of the river. So, we had a problem in August 2022 when in our north highway we had 2 sinkholes that you can see over there. Big holes in the highway, interrupting the traffic and other problems for the city. Those sinkholes were caused by a failure in the invert of the pipe, and that failure was caused by high velocity of the water mixed with water and sand, and that caused this failure that you can see here, and you can see the gravels and the sand here. And what caused that? A high presence of stormwater excess in the sewer line. The expected wastewater flow in these pipes is about 1.2 meters per second, just the wastewater, domestic and industrial. But we measured about 8 cubic meters per second there, so it's a huge stormwater excess. And that excess was due to more than 50 misconnections in the pipes. So we checked, we conducted a survey in the field, and we saw that we have a lot of stormwater connected into the sewer lines. And we are going to talk about specifically these 2 great inlets, these 2, connected directly to our interceptor sewer. And the first we thought was to make the traditional solutions, just to lay a new pipe and connect the great inlets into the sewer network, the stormwater sewer network, and convey the water to the main river. 2 configurations of this pipe can be shown here, but we didn't want to make the traditional solutions because we are trying to think different. We were participating in Reconnect project with the Eleodora Basin that our co-worker Angelica presented this morning, and we were trying to make different approaches. So maybe this is a very small case compared with the large-scale NBS we have seen all day, but it's the same principles. We just try to mimic the natural processes. So we conducted an alternative analysis. First, we analyzed to lay infiltration field with manholes, or to make a detention concrete tank, or to make a dry detention basin with infiltration trenches, or to construct a geocellular infiltration system. And after a cost-risk analysis, we selected the geocellular infiltration system. So, for the detailed design of this system, first we conducted an infrastructure location. This is one of our columns of the metro elevated system. We identified all the trees, We made the hydraulic conductivity measurements, detected public services like gas, water pipes, and sewer pipes. We did several tests for the soil in order to make stratigraphic profiles, and that was the physical characterization. The next step was to make the hydrologic characterization, and the traditional way to do this in sewer lines is this one. Use IDF curves with a time of concentration calculated with empirical formulas, Kirpich, and all of those from an hydrology of maybe another time, but this is the way we calculate sewers now. But we wanted to do something different, and we obtained data from our warming system that has time series data for precipitation with 1 minute step, so it's a very good data. And one of our co-workers developed an app for calculate frequent events with recurrence curves to estimate the distribution of the rain in the time, and to calculate the time, the duration of the storms in a very approximated way. So we made those two approaches. And for the definition of the drainage basin, we conducted a two-dimensional surface modeling in the software Iber made by the Polytechnic University of Catalonia, and we modeled a big domain. We conducted this two-dimensional surface modeling, and we obtained this that this was the basin, the little catchment that was draining to the two great inlets that are over there. So we had the area, we had several estimations of precipitation and intensity and volume. So we obtained several volumes. So the next step was with which volume we select. So we decided just to select 90 cubic meters because we thought it was like a median value for the design, because the values are with a high dispersion. So the next step was to make the final layout. We didn't want to intervene the trees or the vegetation there. So we separated the 19 cubic meters volume in 3 modules: the south, the middle, and the north. And here we can see an isometrical view of the system. In the ends, we can see the north great inlet and the south great inlet. The storm water goes in there and then passes through a great chamber to collect the sediments and big floating trash and that kind of thing. We have a measurement chamber where we can measure the flow. We can measure level in the modules too, and the same goes this way. So some pictures of the construction of our little SUDs. Here is the construction site and a bird's-eye view of the site in the construction. And the next steps we have is the data collection from the flow and level sensors, the analysis of collected data, the replication of this kind of analysis to other problems in our sewer system, and a technical standard proposal that we can integrate into our sewer design guidelines. And the workers were very happy because this was the first time we conducted this kind of construction in our city. So I think it was a very successful project, and maybe it's not so big like the other projects we have seen today, but I think it's important because it's getting in another way of thinking, a shift of thinking in the sewer designers. So, thank you very much.
Thank you. So, do we have questions from the audience?
Thank you very much for the presentation. It's very interesting. It's Albert Chen from Exeter University. So you have done this analysis in the planning process to also use the model to analyze how it will perform. And you will also install the infiltration system there. So have you really compared, so how it's functioning in the reality compared to what you've done in the model planning process?
We haven't because this installation was just 1 month ago,
Okay.
so we don't know. But I'll show you later, maybe in another conference.
Thank you.
Do we have any more questions for Anna?
Yes, only one, very fast. I was surprised in the middle of the presentation. Did you simulate in the model the effects of the chamber?
No, we just use the model. It's a surface model, not an infiltration model or no. Just to calculate the volume. Just
Do we have more questions? Okay. Well, then we shall move to our next presentation.